Okay, right. Now can you able to see the screen?
Yeah.
Right. So now name node, job tracker, secondary name node, slave node. So these are all known as the master nodes. And what are the slave nodes? The data nodes and task trackers are the slave nodes. So every Hadoop cluster will have some one master and will have multiple slave nodes. Okay, so now what name node contains? The metadata, right? The data which is going to written into the data nodes, that reference is written into the name node, right? I'll teach you what is a job tracker and what is secondary name node later. Okay, so this architecture is a Hadoop architecture. Now so this is if you are running Hadoop before 2.0 versions. Okay, Santosh, don't get confused. So
Yes.
the Hadoop latest version is 2.7.0. Now we always tags like Hadoop before 2.0 and Hadoop after 2.0, right? So every feature, every functionality will classify using two ways. One is after 2.0 and before 2.0, right? So Hadoop before 2.0, suppose in your office, just check which version you're running. Suppose if you run the command Hadoop space version, it will show you the Hadoop version, right? So you can able to see the screen. Just a second, I'll change the font size. Okay, can you now see which version I'm using now? The recent version, that is 2.7.0, the new version of Hadoop is. Okay, so now Hadoop we have before 2.0 and Hadoop after 2.0, right? Now Hadoop after 2.0, so we have multiple name nodes are available. Suppose if someone will ask you the question, in a Hadoop cluster how many name nodes we can able to configure, right? This is your interview question. Okay, Santosh, now which answer you have to tell? uh, Generally, if you are using Hadoop before 2.0, we'll have only one name node. Okay, so we cannot have the two name nodes. But Hadoop after 2.0, to make the cluster high availability, we will have two name nodes. Okay, we can able to configure multiple name nodes in Hadoop 2.0 onwards. Okay, so now if you are taking about Hadoop 2.0 onwards, so now what are the masters? Right, master nodes are, so we have a name node is available. Okay, and we'll have some extra node. That node name we call it as a HA node. Okay, or some clients will call it as a shared node. What we call it as a shared node. Okay, so one name node and other one is a high availability node or HA node or shared node, right? We'll have the two name nodes and we'll have a one secondary name node. Okay, now instead of the job tracker we will have resource manager. Okay, instead of the job tracker, what we have a resource manager, right? So these are the masters. Now what are the slave nodes? Right, here slave nodes are the data nodes are the slaves, and instead of the task tracker we'll have a node manager. What we'll have a node manager. Got it, Santosh? Any confusion? right? So
No,
what are the master nodes in Hadoop before 2.0?
the master node, job tracker, and secondary name node.
Right. So after 2.0 it is name node and
Head node.
high availability node.
Yeah.
Okay. Instead of the job tracker, we'll have a resource manager. Okay. And instead of the task tracker, we'll have a node manager. So this is Hadoop after 2.0 onwards. Okay. I'll teach you what is a resource manager, what node manager, right? So we'll see step by step. As of now, just try to remember these things as it is. Okay. Now, so Hadoop is running, right? Means, suppose if a cluster is running with Hadoop, means we can say that so SDFS is running and MapReduce is running. Okay, so what it means, if a cluster is running with Hadoop means in that cluster SDFS is running and MapReduce is running. So this MapReduce is where we have the MapReduce. The MapReduce Hadoop before 2.0 we call it as a MapReduce. Okay, so Hadoop before 2.0 this environment we call it as a MapReduce, or sometimes we call it as a MapReduce version 1. What we call it is MapReduce version 1, MRV1.
One.
Okay, so it's a MapReduce. Now Hadoop after 2.0 we don't, instead of the we'll have the MapReduce. Along with the MapReduce we have some extra architecture, that is yarn. What we call it as yarn. Yarn stands for yet another resource negotiator. Okay, Hadoop 2.0 onwards means it is known as a yarn. Okay, if somebody says Hadoop 2.0, then what you would identify it as a yarn cluster. Okay, if it is Hadoop before 2.0, then it is a MapReduce cluster. So here,
Map reduced.
yes, now Hadoop before 2.0 we have to run only MapReduce jobs, right? And it doesn't support any jobs without MapReduce. But Hadoop 2.0 onwards, we can able to write non-MapReduce jobs. Okay, so what is the advantage that one? We can able to run MapReduce as well as we can able to run non-MapReduce jobs in Hadoop 2.0 onwards. So that is the specialty in Hadoop 2.0. So this Hadoop 2.0 is known as a YARN, which stands for yet another resource negotiator. Okay, so in the Hadoop 2.0 onwards we can able to run MapReduce jobs, and also we can able to run the non-MapReduce jobs. Okay, so now this is here it's a MapReduce version 1. So suppose in Hadoop 2.0 if you are using a MapReduce, then it is a MapReduce version 2. What we call it as MapReduce v2 version 2, right? That is MRV2. We call it also MapReduce version 2. Okay, Santosh, any confusion here?
No.
Right. So this is Hadoop before 2.0 and Hadoop 2.0 after Hadoop 2.0. So now if a cluster is running with Hadoop means either SDF is running and MapReduce or YARN or MapReduce is running in that cluster. Correct? So now what are the SDFS processes? SDFS means what? The file system where we store the data. MapReduce is the job data processing system where we are going to process the jobs, right? So when suppose I wrote a job, suppose I'll take an Hive terminal and I want to create a job. I want to write an Hive program. So whenever you write a program in Hive, so this Hive program is known as a job. Okay. Now this job is going to be executed. Correct. So now if SDFS means in a cluster, SDFS is running means name node is running and data node is running and secondary name nodes are available, and HA node if available, HA node. So these are all available. Okay, so these are all the SDFS processes. What we call it as? We call it as a SDFS daemon, means which are related to only the file system, the files. Now if you want to run a job, right, so that is known as a map reduce, right? It's a map reduce daemons. So now we classify what are the map reduce daemons: job tracker, task tracker, if you are using a resource manager, or node manager. So these are known as MapReduce or yarn processes. Okay, means suppose in a cluster if you started SDFS, that is it indicates you have started name node, data node, secondary name node, HA node you have started. In a cluster you have started a map reduce, means you are able to run with a job with a job tracker, or you can able to run a job with a resource manager. Suppose you have started SDFS, a cluster is running with SDFS, but there is no map reduce, means we can able to store the data, but we cannot able to write the map reduce. Okay, see here. Now suppose this is a clustered. Now so this one I am taking it as a name node, right? So we have an extra node is available, so that we call it as a HA node because we are running Hadoop 2.0. So it is a HA node, and we have some another node is available, that is secondary name node. Okay, as of now remember it as a secondary name node, right? What is a secondary name node, what we'll do with the secondary name node, we'll see those things later. Okay, it is a secondary name
Okay.
node. Okay, right. So if it is a primary name node, so this we call it as a secondary name node. Okay, name node, HA node, secondary name node. Now so these are the data nodes. Okay, data nodes. Okay, now see here in the data nodes means internally what we'll have, we have an SDFS. So this is a master, and this part we call it as a slave. Okay,
Slave.
right? So this part what we are calling it as a master node, and so this particular part we are calling it as a slave. Okay, now in each data node, so what the data node contains your actual data. Suppose what I want to do, I have a command. So what is the command? That is Hadoop fs hyphen copy, or you can see a command copy from local. What it will do, it will copy a file from your system to the Hadoop file system. So which file? Suppose I have a file, the file name is pradinfo.txt. Some file I want to copy. pradinfo.txt is a file name. Where I want to copy? I want to copy in a SDFS, that is under user in a cloud era. There is a directory Ajay. In the directory, uh, again the prod is a subdirectory. Now I want to copy the file this location, that is from your operating system, the file name in my system, my documents, I have a file that is fraudinfo.txt. Now I want to copy this file to the SDFS, means where the SDFS is available. Now SDFS is available in all the three data nodes. Okay, so we are having SDFS here, we are having SDFS here, we are having SDFS here. Just second, Santosh.
Hello.
Yes,
Hello.
Santosh. Santosh. Hello.
Yes. Yeah, yeah, I can hear you.
Yeah. Okay. Now this pradinfo.txt file, I want to copy to the directory product. Now this file pradinfo.txt physically copied to the all the data nodes, right? Yesterday I told Hadoop is a distributed data file, distributed data processing system. Means every file which you are going to write is going to be distributed to the multiple data nodes. Now this file is equally distributed to, it will be divided into the small size of chunks, and these chunks are equally distributed into the data nodes. Okay, got it? Now that
Okay.
is, some part of the data is written into the data node 1, and some part of the data is written into the data node 2, some part of the data is written into the data node 3. Means your actual data, suppose this pradinfo.txt contains 1000 records, then 1 to 350 is available in data node 1, 351 to 700 records are available in data node 2, 700 to 299 is available in data node 3, right? In like this, the data is going to be distributed. So now the actual data of this pradinfo.txt is written into the data nodes. Now this path, which path now? So where pradinfo.txt is available, right? In slash user cloudera, right? That is written into the name node, only this path. Okay, so what it contains now? The path of the file, that is in a user, in a cloudera, in a directory ajay. So there is a subdirectory prod. So in that one, the file prod info and the date and time when it is created, and privileges for that file is written into the name node. Got it now? What a name node contains? Now this path is written into the name node, and the actual content of this file is written into the data nodes. Got it now? Santosh, clear?
Yes. Yes.
Okay, so your actual data, because these are the data nodes. So your actual data is written into the data nodes. Now the reference of the data, the metadata, or index of the data, are a tree kind of structure: directory name, subdirectory name, and the file name. This location of the file is written into the name node. Got it? Now, so we have a file. Which file it is? Prod info. Now what I am going to do is, so from the terminal, a user like you or me, I just want to run a program. I just want to run a job. That is a client. Okay. So what he did in his machine, he wrote a program in Hive. Direct select count of star from EMP or prod info. This is a job, right? The user or the client
Mm-hmm.
wrote this job, right, in his system. Now this job, right, client means now this is a client. Okay, so if I write show tables, right, one table is there, sample underscore 07. What is the job? Map reduce job. I want a what a program, that is select count of star from sample underscore 07. So this is the job which I'm going to write. So when I press this job, when I wrote the job, now this job is taken by the job tracker. Who will take this job? See, now this job is taken by the job tracker, and this job is executed as a map reduce job. Correct? Now whenever a client enters a query, now the job tracker comes into the picture. Okay, what it is? The job tracker comes into the picture. Where job tracker resides? Job tracker resides in the machine where we have a name node. Okay, name node and job trackers are available in one machine. Data nodes and task trackers are available in one machine. Okay, so how many data nodes will have? That number of task trackers will have. How many name nodes generally will have? We'll have only one name node. So how many job trackers will have? Only one
One.
job tracker. Now see here, whenever this client enters a job, this job is taken by the job tracker. Now after that, so what he's looking, the client wants the information about the prod info. Now where this prod info is available? In the data nodes, right? In which data node this information is available? It is written into the name node. So first the job tracker takes the request from the client and it goes to the name node. In the name node it find out the location of the file in which data node this file is available. Then the job tracker comes to that particular data node and it will assign the job to the task tracker. Okay, now job tracker will take the request from the client, then it goes to the name node. In the name node it will identify, it will find the location where data nodes are, where the data, in which data node the data is available. Now job tracker comes to that particular data node and it will assign the job to the task tracker. Now task tracker will execute the job and it will give the output back to the job tracker. Then the job tracker will give output back to the client. Right? Yesterday I have given example, right? I am searching for, right, Santosh, where he is available in some room. Suppose if somebody knows that somebody is a name node, because if instead of searching in all the machines, if you talk to this person, he will tell you where the data is available. The same thing now. So because there are the 1,000 nodes are available in a cluster, so we cannot search in a 1,000 nodes in a 1,000 node cluster. So there is 1,000 hard disks are available. So where you search for the data? Correct. It's impossible. We never directly trace the data into the data nodes. We don't know that which data is available in a which data node. So this is written into the name node. Santosh,
Yes.
this is an important point. We don't know that in which data node the data is available. We know that in all the data nodes, this file is available. Right? Particularly
Hmm.
which data is available in data node 2, which data is available in data node 3, we don't know. Nobody
Okay.
knows. Who knows that? Only name
Job
node.
tracker.
Only name node knows that.
Okay.
Job tracker won't know that. Job tracker goes to the name node and it will ask the name node that where the data is available.
Okay.
The second. Santosh.
Yes.
Okay. Now see, right, the data is available in some data nodes. Now which data is available in which data nodes? Nobody knows that except the
Okay.
name node.
Name node.
So if your data node goes down, nothing is going to happen. We don't, it doesn't make any issue with the job processing. But suppose if your name node goes down, okay, so can we able to trace the data in a data nodes?
No.
Right. The second line. Okay, so that in a cluster, the name node is the important one. Name node is a single point of failure. So the reason for the cluster is down means the name node is down. Okay, so name node is a single point of failure. Got it? Right. So if the data
Yes.
node is available, Okay, if the data node is goes down, so it doesn't make any kind of issue with your job processing. But if your name node goes down, then it's a name node is a single point of failure. Okay, right? So that if your name node goes down, if you're then the entire cluster will we thinks that the cluster is down. That's it. So now what we have to do? So if in the Hadoop 2.0 onwards, if we have an high availability node, then if your name node goes down, then immediately we can make this HA node up and run. So that so
Okay.
the cluster will get 24 by 7 high availability. Suppose if you don't have the HA node, if your name node goes down, so up to some point of time we have to lose the data, right? So this I'll teach you
So,
again in some other session, because here you will get a confusion for that if I'll teach that one.
so
Okay,
basically, HA node is a backup node, right?
no, there is no backup node. You'll take the backup into the disk. So these are the there is no backup nodes here in the cluster right now. I didn't took the concept of backup. If you want to take the backup of this name node, we can able to take the backup. So we have some tool is available, so that is different. Okay, so here HA node is
Okay.
not a backup node, secondary name node is not a backup node. But see, sometimes some people, if you go through Google, so they will says that secondary name node is a backup node, HA node. So there is no back, these are all the not backup nodes. So the snapshot of the primary name node is written into the HA node, secondary name node, and whatever you are writing into the name node, the same writes will be written into the HA node, two writes.
Okay.
And whenever the checkpoint occurs, the snapshot of the primary name node is written into the secondary name node, because it's a primary name node. What is a primary memory? It's a temporary memory. The data which is in a RAM is a primary memory, right? Suppose if your system is going down, shut down, means you have to lose all the data, correct? Because it's a
Yes.
primary memory, the data is written into the RAM temporarily. So that's the name node will have the data into its primary memory. Okay, so that is the reason if your name node goes
Okay.
down, we have to lose the data. Fine. So now in a cluster, how many job trackers will have? We can have,
One
right? So where job tracker resides?
in the name node.
Right. So because suppose if we you have to process many number of jobs are there, and if we are unable to accommodate that number of resource in one machine, in that case we can able to accommodate, we can able to configure job tracker as a separate node. Okay,
Okay.
so most of the times job tracker resides in the machine where name node is running. Okay,
Okay.
suppose if you are having more number of jobs to be processed, okay, and if you are unable to accommodate that number of resource in one node, then we can able to configure job tracker as a separate node, right? But most of the times we'll have only one job tracker in
Okay.
name node. Okay, so this is a clear,
Yeah, it's clear.
right? Now, so in Hadoop 2.0, do we have a job tracker?
Hadoop 2.0, that is before or after?
Hadoop
Before
2.0,
we have the
Hadoop 2.0, it's
before
a
we
before
have
or after?
before
Hadoop 2.0 means 2.0 onwards. Is
or
it?
from
Yeah.
2.0 onwards we have the job trackers.
Yes. No. Before 2.0, we have the job tracker.
Okay. After 2.0 we have the HA node, secondary nodes, right?
No, secondary name node is there in the before 2.0 and after 2.0. Uh, After
Okay.
2.0, we'll have a yarn. What we'll have?
Yeah.
Yarn, right? So yarn in the sense, now see, Santosh, here observe this diagram. What the job tracker is doing? First, it is going to the, it is taking the request from the client. Okay. After
Okay.
that, it is going to the name node. Then it is finding the reference. After that, it going to the data nodes where the data is available. it is assigning the job to the task tracker. After that, it is waiting for the output from the task tracker. After that, it takes the request output from the task tracker and it will assign it to the U client. Means one job tracker is able to do all these things. So till this job completed, so remaining jobs are in a queue. Okay. So now here
Yes.
what the job tracker is doing, it is waiting, right? When the task tracker completes the job, so it is waiting for the task tracker to complete the job. So once this job is completed, then only it can able to take the another job. So still until then all the jobs are in a queue. Okay.
Okay.
So now in Hadoop 2.0, what we did in the job tracker responsibility is distributed to the two processes, that is a resource manager and application manager. That is, in the previous there is only one employee has to do all these things. Okay.
Okay.
Now in Hadoop 2.0, this same job will be given to the two employers. One employer is a resource manager and another one is a application manager. Okay.
Okay.
So the job of the job tracker is distributed to the application master and resource manager. Now application master will process the job, resource manager will allocate the resources. While resource
Okay.
manager are allocating the resource for the job one, then application master will take another job from the client. Means we can able to process multiple jobs simultaneously. Okay.
Okay.
Previously I am the one working, right now you and me are working. So when I am working, so you can able to take another request, right? So this is
Mm-hmm.
example. So the job tracker's job is now distributed to the distributed to what are the processes names
Resource manager and
and application master.
yes.
Okay. So job tracker is application master and resource manager. Now instead of the task tracker, what we have, node manager.
Board managers. Okay.
Okay. So these are the Hadoop daemons and processes, right? So master, this is a master and these are the slaves. And if you talk
Yes.
about SDFS daemons, so suppose you have to start SDFS means, so you have to start these daemons. If you are starting MapReduce area means you have to start these scripts. So generally we have a script start hyphen dfs.sh. So what it will do? It will start SDFS. Okay.
Okay.
Then we write start hyphen mapread.sh. What it will do now? It will start the
Map reduce.
MapReduce. If you write start hyphen yarn.sh.
Yam.
So what it will start? It will start the
Yam.
yarn. Suppose you have started only the SDFS. Can you able to run the
Mm-hmm.
job?
No, yes.
Okay, so we have only started the SDFS. We have not started the MapReduce. Can we able to run the job? No,
No.
because if you started the MapReduce means job tracker is started. See here in the diagram.
Yes.
So who is taking the client job? The job tracker.
Job
But
trackers.
you have not started the MapReduce. Means job tracker is not available. So how your request is processed? Correct?
No.
Right. So here, so if we have SDF is running, we can able to store the data and we cannot able to write the jobs. So to run the jobs, we require a map reduce. So that we have to start the map reduce. That is the script name is start hyphen mapreduce.sh. Or
Yes. Yes.
if you want to run the yarn, then you have the script that is start hyphen yarn.sh, which will start the yarn in the cluster. So who will write this start DFS, start MapReduce? So generally, if you are using Hadoop from the Apache, we'll have another script that is start hyphen all. What is the name
All.
of the script?
Okay.
All. So what it will do? It will start everything. Okay, it will start all the Hadoop daemons.
Okay.
Okay, so this we'll see in tomorrow session. I'll show you how to start SDFS, how to start the map reduce and everything. Right, so if you're it's a SDFS, so let me connect to that one. I'm connecting to the cluster through the putty. Right, so what is the IP address which we have connected? Write the IP address of the cluster where you have configured. Right, so here it is available on 192.168. Right, so just I'm copying this. So here this is a mapper cluster, Santosh.
Okay.
Copy this and open a putty and write the IP address. Open it. Right, login as a mapper and password is a mapper. Right, so now I have connected to the mapper cluster through the terminal remote connectivity. Right, so in your office you will be given access to this terminal and a browser. So through the browser we'll connect to the server and we'll write the jobs.
Okay.
Okay, so if you write yarn, so now you have to start the yarn. So to start the yarn, so we have the command, right? Can you able to see yarn space resource manager, yarn space node manager.
Yeah.
See now, resource manager, node manager. So this we have to start the yarn. Okay, we'll see this how to connect to the name node. uh, Remember, I'll see it now itself. Right, we'll see the web UI user interface. Right, name node runs on the port number 50070. Okay, so suppose if you want to see the statistics of the name node, information about the name node, right? So then we it will available in a port number 50070. Now see, this is the name node. What happened? Okay, launch view. Okay, see now, see now user mapper. So if you create a directory, the directory will be listed here. Right, now we can here we write everything. Okay, so file browser. So it is a file browser, right? If you open the mapper control system, now see what we are running. Node manager. Can you able to see here this one,
Yeah.
right? Resource manager is running and history server is running. Hive server is running in this machine. Okay, so this is a rack information. You can see number of nodes in this rack. Okay, so this is my node, and so these are the information about the my node, right? So whatever the mapper is running, so the mapper is information and the data nodes information here you can see.
Okay.
Okay, I'll show you this in tomorrow because let me complete this topic completely, then you can able to understand a little bit clearly about this. Okay,
Okay.
right? So any confusion here, Santosh?
No, no.
Okay, fine. So as of now, so today I'll end the session, right? So we'll see in tomorrow session the remaining thing.
Okay.
Okay, so I'll give you the steps to configure Hadoop in your machine. You told you are having 8 GB RAM.